Hello guys, in today's video we will be seeing about normal form or canonical form. So in previous video we have seen what is echelon form, right? So echelon form is used to find the rank by using only the row transformations. Okay, so what is this normal form means? Normal form or canonical form, one and the same. Okay, these form is used to find the rank of matrix by doing row and column transformation. That means there we have interchanged, in echelon form we have interchanged rows, we have multiplied with some integer for the complete row, so the main operations are only row, right? So here in the normal form or canonical form we will use column transformations as well. Okay, so what is the end result? How do you find that? Okay, we have achieved our answer or we have completed our solution. That means after doing some series of rows and column transformations you will get identity matrix. Okay, there in echelon form what we used to get all the zero rows at the bottom and non-zero rows will be the rank of matrix. So here we will use row and column, right? So what happens in column? It is in echelon form it is only row. That is why we will get zeros in the upper triangular matrix. Now in the canonical form we are using row and column transformations. So we will get zeros in the upper triangular matrix and the lower triangular matrix. That is why we will get the identity matrix. That means except the diagonal elements, all the other elements will be zero. Okay, so whatever the identity matrix we get, that will be the rank of the matrix. For example, here I took 3 by 4 matrix, right? So on solving this matrix, if I get 2 by 2 identity matrix, then rank will be the 2. Okay, that is how you have to find the canonical form. And one more thing, even though you solve the same question with the echelon form and the canonical form, still the rank will be same, or if you follow the general method also, still the rank will be same. So you make sure that whenever you perform any kind of this canonical form or echelon form solutions, after achieving your solution or rank, try verifying your answer with the basic method, that is det A method. Okay, that because this canonical form and echelon form definitely they'll ask you in the 10 marks question or 15 marks question only, they'll not ask for the less. So in echelon form and this canonical form, I would say canonical form is more important than echelon form, because nowadays every question paper, I mean for the past few years we are seeing this canonical form only. Okay, echelon form also they asked, but now they are not asking, so mainly concentrate on this canonical form as well. Okay, now let's see how to solve this solution. So first what you have to do, you have to write the given matrix: 3 4 2 1 4 3 3 0 5 minus 10. So the same operations, like you should, whatever the operation you do, you have to do it for the complete row or complete column. That means if you want to change the column, do change the column. If you want to change the row, you have to change the row. So unless when you will do, you should get the identity matrix. That means like this way. Okay, if you have more zeros, then 0 0 1. So now I got identity matrix as 3, right? So the rank will be 3. For example, you might get like this also, all zeros and 1 1 here. So this is what identity matrix of 2 only, right? So this rank will be the 2. So based on the identity matrix we have obtained, we will decide the rank of the matrix. Now without, first again there is one trick here. What is the trick means? First try making zeros for the upper triangular. Okay, you first see, listen here again, you have to make zeros this way. Okay, in the first column, after the first element, you can do first element as 0 also if it is possible. Okay, if not, try making all the zeros first here and then go to this way. Okay, row wise, first element column you have to make, and the first element row you have to make, and then go to next, make this element, all the down elements as zeros and the horizontal as zeros. Okay, this is how you will achieve canonical form. You can just do it in any way, but if you do this way, you'll get the answer very quickly and perfectly with just few steps rather than doing some random transformations. Okay, so as I said, first I will try making zeros this way. So for that, what I can use, I can change R2 row with R2 minus 2R1 and R3 row with R3 minus 3R1. So then you will get zeros, right? So again I'm telling you, if you are updating any rows here, don't use them in the transformations or operations, okay? Like for the next. So for the first time, do every single transformation in every single step. So once you get practice, try doing like similar kind of operations in one step. That will be easy, okay? So since I've explained you clearly in the previous video, I'm going on with the bulk steps now. So what you will get, 1 2 3 4, because first row is, we did not update anything, so here 0 minus 3 minus 2 5 0 minus 6 minus 4 and 22. Yeah, see, if you observe here, I have made first column all as zeros, right? Now what I will do, I will try reducing this 6 4 22 because they are bigger numbers, so we'll try reducing them. So for this all 6 4 22, we can divide the number, these numbers by 2. Yes, so I'll divide it with minus 2 so that we'll get rid of minus, and that will be easy for us to solve the positive numbers. R3 is divided by R3 divided by minus 2. So what you will get, 1 2 3 4, 0 minus 3 minus 2, and then 5. Okay, next 0 3 2 11. Okay, here you will get minus, I guess. Yes, minus. Now we have achieved. Now this is also minus, I forgot to write there. Okay, now what we can do is, just to make sure that if we observe here, if we add these two rows, that means R3 and R2, we can make these two numbers as zeros, right? Leave it about this, we can just at least make these two as zeros. So what I will do is, R3 is updated with R3 plus R2. So the result will be 1 2 3 4, 0 minus 3 minus 2 minus 5 0 0 0, 11 plus of minus 5 is 6. I'll write it off 6. Okay, this is the latest matrix we have. Now we will continue the solution again. So if you observe here, we cannot make any row transformations now. Why for now is, we have made these zeros and these zeros. Here we have option to make column transformations also, right? So what is our next step? Once you are done with the zeros, you can go for column transformations. So I will try making these numbers as zeros. Okay, this first row as 0. We'll see if, okay, now what I'll do is, for column 2, I'll do with, for column 2, that means this one, if you observe carefully, we can make this complete row, this complete number, whatever the 2 we have, if you multiply with the row 1, like means C2 should be updated with 2 times of C1, and you have to subtract these 2. That means you should multiply this column with the 2. You'll get 2, right? Then if you subtract 2 minus 2, you'll get 0. Similarly, for this column also, if I multiply with the first column with the 3, then it will become 3. Again, 3 minus 3 will be 0. You have to do subtraction operation. So similarly, for the 4 also, we can multiply with the 4 C1 and subtract C4 and C1, right? So this is the advantage with the 1. If you try making the 1 digits, then you can just directly multiply with the number which you want to subtract, and then you can make it as 0. So 1 will be easiest thing. Okay, now we will do the operations first. C2 minus 2C1, C3 I'll update with C3 minus 3C1, C4 updated with C4 minus 4C1. Now what you will get? You'll get 1. So you'll get 0 here, 0 here, 0 here. Already we have 0 here, and here it will be we are updating C2, right? So anything into 0 is C3, so minus 3 will be same as it is, and for this one it will be minus 2 into, we are doing this row C2, right? Sorry, minus 2 into 0, again it's 0 only. So 3 into 0 is 0 only, so whatever the value we have earlier, we will have that value only. That means we'll get minus 2, minus 5, 0, 0, 0, 6. Okay, first it will be a bit confusing. Even it is difficult for me to explain this way because I could not understand whether you are understanding or not. So I'm trying to explain it again and again, so don't get confused with the video. Try listening it very carefully. This is very easy actually. Okay, just transformations. You have to just transform the rows and the columns until you get the result. Okay, so now if we observe here we have zeros, here we have zeros, or if we try making this as zeros, these two as zeros at least, then we can observe some diagonal pattern, right? So what I'll do is I'll try making these two elements as 0. Since this is the diagonal element, don't try to make it as 0 first. First, how we have discussed, if the element is this one, try making down and horizontal. If you take this element down, horizontal, so this way you have to, if you have chance to make this element also as 0, then you can do it. Okay, if not, don't disturb that. Now what we can do, operation C3 is updated with 3C3 minus 2C2. Okay, then what happens? C3 means this one, 3C3, 3 2s are 6, minus, let it be 2C2. 2 into 3 is what? Again 6. Minus into minus plus. So minus 6 plus 6 will be 0. So this will be 0, right? So similarly we can multiply with the 5 here. Then it will be also 0. C4 is updated with 3C4 minus 5C2. Then what you will get? 1, 0, 0, 0, 0, minus 3. Minus 3 will be same. We did not update 0, 0, 0, 6. Okay, now if you try making any kind of subtraction of rows or addition of rows or subtraction of columns or addition of columns, all the zeros will be disturbed. Okay, why? See, for example, you all may get doubt. First thing you have to observe is you can't do any operation here. Why? Because there are any numbers. We don't have any numbers here, so you cannot subtract or addition. So for this 3 also, in order to make it 0, you have to have some or the other element in the above row or below row. So you don't have that also. So all zeros are there, only the diagonal elements are present. So first I will try making them as ones. Okay, because identity matrix will have 1. So what I'll do, I'll multiply C2 with C2 by minus 3. Then what you will get, and also C4 with C4 by 6. Then you'll get 1, 0, 0, 0, minus 3 by minus 3, minus minus cancel, 3 ones are 3. So 0, 0, 0, 0, 0, 1. Now if you observe here, we have identity matrix of order 3. But you will get out only the two diagonal elements are there. So how can you say that it's 3? If we observe here, this is the last element, right? So if we move this complete column to here and this to here, that means column transformation, then we will get the identity matrix, right? So C4 is interchanged with C3. Then the final matrix will be 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0. Now if you observe here, whatever, leave about the 0 rows, if you observe here we have the diagonal that means unit matrix, so it is of order 3 by 3, right? Okay, so now rank will be, it is of order 3 by 3. Now rank will be 3 for this matrix. Okay, so this is how you have to do the canonical form. It is very easy. The only thing you have to understand is how to perform row and column transformations and when to perform them. So again I am explaining you when to choose what. Listen all the points here carefully. Okay, so whenever you are trying to make zeros, first if it is in the echelon or canonical form, leave about that. So the only difference is you have to use more transformations in the canonical form, but the pattern will be same. If you have elements like this, try making zeros for the first element down elements, okay, in canonical form, and then for the next diagonal element down elements, and for the next diagonal elements down elements, and so on. Okay, in this process only the remaining elements also will become zeros sometimes. If not, then it's fine. This is for what? Echelon form. Then if it is canonical form, take first element, try making all down zeros, and then horizontally go this way only. Okay, down and then here. If in the process of making these zeros, other will be also becoming zeros, so you should not worry about that. Your aim is to get as many as zeros. Okay, and one more thing, once you updated any element with the 0 by using some row transformations or column transformations, do not make any transformation such that that 0 will be updated with some integer value. That means you have some element like 0 1 2 3 and 1 2 3 4 2 3 4 5, and you did some operations and you got this 0 1 2 3, this as 0, sorry, okay, this is 0 and this is 2 and this is 2 4 and 2 3 4 5. Okay, you did some operations and you got this, but generally I'm explaining it just for the understanding. Okay, now you made zeros. Now here let's make this as 0 and this as 1. Okay, you'll understand why. I like this matrix again here. 0 1 2 3 1 0 2 4 2 3 4 5. Okay, you have got this matrix after doing some row transformations or column. Now what everyone does is, here we have 2, here also we have 2, so 2 minus 2 will become 0, so we can just update this row. So, or you can, what you'll think is, we have here 2 and here 2 minus 2 is 0, so we can make this row as 0. So but if you do that, what happens? 1 minus 0 is what? 1. It is updating with 0 gone. Here you got 1. Here you will get 0. But what is the difference again? You have only 1 0, right? So you are disturbing it again. So again, to make this as 0, you have to perform again some set of operations. So that is not how you have to move for the solution. First try making this way. Okay, whatever the patterns I told you, try making the zeros in that pattern only, then you will get answer definitely. And try practicing more problems. Don't just look at the solution, please try practicing more problems, only then you will get the matrices chapter perfectly. This is the main thing in the M1 chapter. Chapters. So for M1, what everyone do is, they'll just look at the solution, they'll just see the procedure. Okay, here you have to do the row and column, that's all. But in reality, when you are solving the matrix, it will not be the case. You have to practice, only then you will get the answer. Okay, try as much as solutions you can. Okay, and this is what I wanted to tell you about M1. M1 is not at all hard and it is not so easy, but with good practice and good concept, you can definitely clear the exam. Okay, the main thing everyone does is just looking at the solutions. Please don't do that. You try practicing it more and more. If you want any other questions or any kind of models, please do type that question as a comment for this video or any other video. I'll check and I'll try explaining it again. Okay, thank you.